Now that we have a little bit of intuition on how to deal with limits graphically, let's talk about how to do them algebraically. And in order to do this, we're going to have several different limit laws. And in order to start with that, let's suppose we know a limit of one function f of x. So we'll suppose the limit as x approaches x0 of f of x is equal to some known number L. And now there are several different things that we can say about similar functions. First off, the limit as x approaches x0 of just the function x is just x0. In addition, the limit as x approaches x0 of a, which is just a constant, is equal to a. So the limit as x approaches any number of 5 would be equal to 5. The limit as x approaches x0 of a f of x is equal to al, where once again a is any number. So essentially what this tells me is that I can move a constant in and out of the limit. If I have the limit of a f of x, I can just take the limit of f of x and then multiply by a. Another one, the limit as x approaches x0 of f of x to the p power is L to the p power. Essentially what this one says is that if I have an exponent, I can take the limit of my function and then raise it to an exponent. Now that we've got some of the basics down, let's look at combining functions. So now let's suppose that I know two limits. This time the limit as x approaches x0 of f of x is L, and the limit as x approaches x0 of g of x is M. So now we can combine these in a few different ways. The first says the limit as x approaches x0 of f of x plus or minus g of x is equal to L plus or minus M. Essentially what this says is I can break these limits up over addition. I can find the limit of f of x and then the limit of g of x and then do any of my addition or subtraction depending on what the problem calls for. This next one states that I can break it up over multiplication. So if I need the limit of f of x times g of x, I could find the limit of f and the limit of g and then multiply. The last one we have, the limit as x approaches x0 of f of x over g of x is L over M, provided M is not equal to 0. So I can take the limits of each and then divide them, provided I don't divide by 0, which we will address that issue in a later video. So now that we have this, let's see about using them. I have the limit as x approaches 1 of 3x squared plus 7x minus 6. So now let's try to use these limit laws. First, we do know that we can break things up over addition and subtraction. So that tells me that I have the limit as x approaches 1 of 3x squared plus the limit as x approaches 1 of 7x minus the limit as x approaches 1 of 6. We also had a law that said I can move constants out. So this is 3 times the limit as x approaches 1 of x squared plus 7 times the limit as x approaches 1 of x minus the limit as x approaches 1 of 6. We also had one where we talked about exponents and how we can move them in and out. So this is 3 times the limit as x approaches 1 of x, all squared, plus 7 times the limit as x approaches 1 of x, minus the limit as x approaches 1 of 6. We also said that the limit of the function x is just x0, in this case 1. So this would be 3 times 1 squared, plus 7 times 1. And one of our limit laws also said that the limit of a constant is just that number, so minus 6. So this is 3 plus 7 minus 6, which is 4. And now I have my limit. However, this was a lot of work, and we don't really want to do all of this work every single time we have to take a limit. However, if I notice at this step, all I did was take my original polynomial and plug in the number 1. And this is actually going to work for polynomials. All I have to do is evaluate the polynomial at the limit point, and I get the limit. So let's try another example that doesn't require all this work. Here we have the limit as x approaches negative 3 of x cubed minus 4x squared plus 7x. So all we have to do is stick in the negative 3. I have negative 3 cubed minus 4 times negative 3 squared plus 7 times negative 3. And once we do all of our arithmetic and work that out, we get negative 84. So I have my limit using a lot less work than I did in my last example. Let's try one more. The limit as x approaches negative 1 of x squared plus 9x minus 2 all over 6x plus 4. Well, I said that we can stick in the number provided it's a polynomial, and this isn't really a polynomial. But we can still just stick in negative 1. One of the rules said that we could take the limit of the top and then the limit of the bottom and divide them, and the top is a polynomial and the bottom is a polynomial. So now I have negative 1 squared plus 9 times negative 1 minus 2 all over 6 times negative 1 plus 4. When I work this out, the top ends up being negative 10 and the bottom negative 2, so my limit is just 5.